Hi everyone, I'm Azra. I'm a third year industrial engineering student, and here is my physics project experiment. My aim is to measure the capacitance under different circumstances. For example, in between having air or sponge, and also I'm going to connect them in series and parallel. Now I'm going to introduce you my equipment. I have four metal plates to build a capacitor and my sponges to put in between them. I have cables, I have capacitance meter and my stand.
First, we set up identical capacitors with two parallel metal plates, each measuring 15 by 15 centimeters, and placed them 1 centimeter apart. We started by keeping air between the plates and measured the capacitance using a multimeter, first in series and then in parallel connection, and recorded the capacitance values for both setups. We then inserted a sponge completely between the plates, which has a higher dielectric constant than air, and repeated the same measurements for the series and parallel configurations. For each case, we also calculated the theoretical capacitance values based on the plate area, distance, and the dielectric constant, and then compared them to our observed values. And here are my conclusions. From the experiment, we observed that inserting a sponge between the plates significantly increased the capacitance compared to just using air. We also saw that connecting capacitors in parallel resulted in a higher total capacitance than connecting them in series, which matches the theoretical expectations. Overall, the experiment confirmed the relationship between the dielectric materials and connection types and capacitance. It showed that the dielectric materials' properties and how capacitors are connected can significantly impact how much electric charge the system can store. And for the error analysis, even though the general trend matched our expectations, there were noticeable errors between the theoretical and experimental results. The highest errors appeared in the series connection setups. These errors mainly came from factors like fringing effects of the edges of the plates, slight misalignments, inaccuracies in placing sponges, and measurement limitations of the multimeter. Also, the exact dielectric constant of the sponge may have been different from what we assumed.